We used tables to determine rate of change and determine if it was constant or varying. And what we did was we looked at the change in x and the change in y and decided if it was the same, then it was constant, and if it was different, like it was in example B, it was varying. And then we also looked at proportional and not proportional within those. And so if it has a constant rate of change, then we know that it's linear. However, it also, in order to be proportional, must go through the origin. And so example B, it did go through the origin. However, because it has a varying rate of change, we know that the graph is nonlinear, and so this one is also not proportional. So now we're going to look at some visuals here. We're going to look at some graphs and determine whether each graph shows constant or varying rate of change, and then determine if it's proportional or not proportional. So for part A, constant or varying rate of change, well, because this is nonlinear, it is a varying rate of change. We can see that the slope is negative until it gets to the origin, and then the slope turns positive, and it changes from one point to the next because it's starting to get a little bit more steeper as we push to the edges here. And then when we decide proportional or not proportional, though it does go through the origin, this is not linear, and so this is non-proportional. Anytime that we have varying rate of change, we automatically know that the graph or table is not proportional, because varying means nonlinear and proportional means that it has to be linear, and so those two are never going to go together, varying and proportional. On this next example, we have a line which shows a constant rate of change. Anything that's linear shows a constant rate of change. We're going up 60 and over 1, up 60 and over 1, up 60 and over 1 according to our scale on our graph. And then is it proportional or not proportional? Well, it is a straight line that goes through the point 0, 0 or through the origin, and so this one is proportional. And what's important for us to realize and understand and note is that sometimes with varying, it's always not proportional. Varying and non-proportional go together. Varying means nonlinear. Proportional means that it has to be a line through the origin. So those two are never going to go together. Varying is always not proportional when we're talking about functions. However, when we have a constant rate of change, sometimes we have a proportional relationship, and other times, like we had up here, we have a constant non-proportional relationship. Because it is a straight line, but it doesn't go through the origin. And so we have to be extra careful that when we choose constant rate of change, we really look for that piece of does it go through the origin to decide. If it doesn't go through the origin, it's not proportional. If it does go through the origin and has a constant rate of change, then we can determine that it is proportional.